Have you ever read the same page 3 times, highlighted all the important sentences, and still forgotten everything the next day? The problem may not be your memory. The problem may be that you never truly understood the idea. You only became familiar with the words. There is a simple way to test the difference. Choose something you think you understand. Now close your notes and explain it to a 10-year-old. No technical words, no copied definitions, no hiding behind jargon. Can you still explain it clearly? When your explanation starts to break, you have found the exact point where your understanding ends. This is the idea behind the Feynman Technique, and it can help you learn almost any difficult subject more deeply. The illusion of knowledge. Let's take a simple example. Imagine a student named Maya. Maya is preparing for a biology exam. She reads a chapter about photosynthesis, then she reads it again. She highlights words like chlorophyll, glucose, carbon dioxide, and solar energy. After a while, everything starts to feel familiar, so Maya feels confident. Then her younger brother asks, "What does a plant actually do with sunlight?" Maya begins answering, "Well, chlorophyll absorbs photons, which help with the synthesis of glucose." Her brother looks confused, so Maya tries again. "The chloroplast performs a biochemical conversion." Now they are both confused. Maya recognizes the vocabulary, but she cannot explain the idea. This is called the illusion of knowledge. It happens when something feels familiar, so we assume we understand it. But recognizing an explanation is not the same as creating one. Following someone else's logic is not the same as rebuilding that logic yourself. That is why rereading can sometimes feel more useful than it actually is. The words become familiar, but the understanding may still be missing. The Feynman technique removes that illusion. It forces you to prove your understanding through explanation. Where the technique came from. The technique is named after Richard Feynman. Feynman was a famous physicist who worked on extremely difficult ideas, but he was also known for explaining those ideas in a lively and understandable way. He believed that using impressive words could sometimes hide weak thinking. So instead of asking, "Do I know the correct definition?" he focused on a better question: "Can I explain what is really happening?" The popular 4-step version used today was organized later by teachers, writers, and learners inspired by his approach. So Feynman did not create a formal worksheet with 4 official boxes. He demonstrated a way of thinking. Be curious. Be honest about what you do not know. Break difficult ideas down, and never confuse complicated language with real understanding. Step 1. Choose one clear idea. The first step is to choose what you want to understand. This sounds easy, but many people choose a topic that is far too large. They write, "I want to understand economics," or "I want to understand artificial intelligence," or "I want to understand marketing." But these are not single ideas, they are entire worlds. Instead, choose one clear question. For example, why does inflation reduce the value of money? How does a recommendation system choose videos? Why does social proof influence customers? What is the difference between revenue and profit? A smaller question gives your mind something clear to work with. Now write that question at the top of a blank page. Then close your book, close your browser, hide your notes, and write everything you know from memory. This blank page is important. It removes the support system. It shows you what is actually inside your mind. Many people skip this part. They keep the textbook open and rewrite the definition in slightly different words, but that mainly tests your ability to copy. It does not fully test your understanding. The better approach is simple. Start from memory. Use the source only after you discover what is missing. Step 2. Explain it to a 10-year-old. Now imagine you are teaching the idea to a curious 10-year-old. You do not need an actual child. The 10-year-old is simply a filter. It forces you to use normal words, short sentences, clear examples, and simple cause and effect. Let's say you are trying to understand a supply chain. A complicated explanation may sound like this. A supply chain is an interconnected network responsible for procurement, production, logistics, inventory optimization, and final mile distribution. That sounds intelligent, but can you see what is happening? Probably not. Now, let's explain it simply. Imagine a small bakery. The bakery needs flour. A farmer grows the wheat. A company turns the wheat into flour. A truck carries the flour to the bakery. The baker uses it to make bread. The bread is placed in the shop. And finally, a customer buys it. All the people and steps that move the wheat from the farm to the customer form the supply chain. Now the idea becomes visible. You can picture the farm, the truck, the baker, the shop, and the customer. That is what simple language does. It removes the places where confusion can hide. Words like optimization, integration, and strategic alignment may be useful, but sometimes we repeat these words without understanding what they mean. When you replace a technical term with a clear explanation, you discover whether you understand the idea behind it. But there is one important warning. Simple does not mean wrong. The goal is not to remove every detail. The goal is to understand the basic structure first. Then you can add complexity later. Think of it like building a house. You begin with the foundation. You do not start with the curtains. Step 3. Find where the explanation breaks. As you explain the subject, something interesting will happen. You will get stuck. You may say, "And then something happens," or "the system basically handles it," or "this somehow causes the next step." These phrases are warning signs. They show that your explanation has reached a gap. Most people feel uncomfortable when this happens. They think getting stuck means they are bad at learning. But getting stuck is the most useful part of the process. The gap tells you exactly what to study next. Let's return to the bakery. You may say, "The bakery orders enough flour to meet customer demand." Then ask yourself, how does the bakery know how much flour customers will need? Maybe you cannot answer. Excellent. You have found the gap. You now return to your source and study that one question. You discover that the bakery may look at previous sales, holidays, weather, local events, and current orders. This helps it estimate future demand. Now your explanation becomes stronger. You can say, "The bakery studies how much bread customers usually buy. It also looks at upcoming events. Then it estimates how much flour it will need." You did not reread an entire textbook. You repaired one weak connection. This is targeted learning. Instead of studying everything again, you study the exact point where your thinking became unclear. Confusion is not a wall, it is a map. It shows you where your current knowledge ends. Step 4. Simplify and rebuild. After filling the gaps, close your materials again. Now explain the idea from the beginning. Do not simply attach a new sentence to the old explanation. Rebuild the whole explanation. Your second version should be clearer, shorter, more accurate, and easier to follow. Then read it aloud. This is more useful than it sounds. A sentence can look intelligent on paper, but sound confusing when spoken. Listen for the moments where you hesitate, rush, repeat yourself, or suddenly use a complicated word. Those moments may reveal that the idea is still unclear. Imagine your student keeps interrupting you. What does that mean? Why does that happen? Can you give me an example? What would happen if this part disappeared? Every good question makes your understanding stronger. You continue the cycle. Explain. Find the gap. Study the gap. Then explain again. That repeating cycle is where deeper understanding develops. The power of analogies. A strong analogy can make a difficult idea easier to remember. An analogy connects something unfamiliar to something familiar. It acts like a bridge. For example, a supply chain is similar to a relay race. Each runner carries the baton for one part of the journey. The farmer produces the material, the supplier prepares it, the transporter moves it, the bakery turns it into a product, the shop gives it to the customer. If one runner is late, the whole team is affected. That analogy helps us see that every stage depends on the others. Here's another example. Compound interest is like a snowball rolling down a hill. At first, the snowball is small. As it rolls, it collects more snow. The larger it becomes, the more snow it can collect. Money can grow in a similar way. You earn a return on the money you started with. Later, you may also earn a return on the growth already added. But remember this, an analogy is a tool. It is not the full truth.
A supply chain is not literally a relay race. Money is not literally a snowball. A good analogy explains one important relationship. A bad analogy gets stretched until it becomes misleading. So always ask, how does this analogy help, and where does it stop working?
Common mistakes. Now here is where people often get the technique wrong. The first mistake is teaching while looking at the textbook. When you keep reading from the source, you are not fully testing yourself. Close the source first. The second mistake is replacing jargon with vague language. Saying, "this thing affects the other thing," is not a simple explanation. It is an unclear explanation. You still need to describe what actually happens. The third mistake is choosing a subject that is too broad. Do not try to explain all of psychology in one page. Explain one question, such as, why does scarcity make something feel more valuable? The fourth mistake is oversimplifying until the explanation becomes incorrect. Simple language should remove confusion. It should not remove important truth. And the final mistake is stopping after the first explanation. Your first explanation is not the final product. It is a diagnosis. It shows you where the problems are. The learning happens when you repair those problems and try again. A practical 15-minute version. You do not need hours to use this technique. Try this simple 15-minute version. For the first 2 minutes, choose one clear question. For the next 5 minutes, explain it from memory. Then spend 3 minutes circling every weak sentence, unexplained term, or missing connection. Use the next 3 minutes to study those specific gaps. Finally, close everything and explain the idea again. Then test yourself later. Try again that evening, or the next day. If the explanation still makes sense without your notes, the idea is becoming part of your long-term understanding. Where you can use it. Students can use the technique after every lesson, close the book, and explain the main idea on one page. Office workers can use it before an important presentation, remove the company jargon, and explain what the project is really trying to achieve. Business owners can use it to understand how their business makes money. Where do customers come from? Why do they buy? What does it cost to serve them? Where does the profit remain? Job seekers can use it before interviews. Can you explain your past work clearly to someone who knows nothing about your role? And creators can use it before making videos. Before teaching thousands of viewers, explain the idea to one imaginary beginner. That simple explanation can become the foundation of the entire script. Final takeaway. The Feynman technique does not magically make every subject easy. Some ideas will still require time, practice, mathematics, experience, and repeated effort. But the technique does something incredibly valuable. It makes your confusion visible. It separates words you recognize from ideas you truly understand. It turns studying from collecting information into building a clear picture in your mind. So the next time you finish a chapter, course, meeting, or video, do not ask, "Have I seen this before?" Ask, "Can I explain it clearly?" Choose one idea. Explain it simply. Find the gaps. Repair them. Then explain it again. Because the clearest sign that you understand something is not that you can repeat the definition. It is that you can make the idea clear to someone else. And remember, when your explanation breaks, you have not failed. You have simply found the next thing you need to learn. What is one difficult subject you want to understand better? Write it in the comments, then try explaining it without using your nuts. And if this video helped make the Feynman technique clearer, subscribe for more simple explanations of useful frameworks, mental models, and learning methods.